Dear children, so last class we learned uses of some common non-metals. So which are the non-metals whose uses? Last class we learned carbon in the form of coal, graphite, diamond, iodine, chlorine, nitrogen, oxygen, sulfur and hydrogen. So these are some common non-metals that we use in our daily life, and for which we learned about their uses, how we use these non-metals in our daily life. So today we'll be learning metalloids. Now there are four types of elements. These are metals, non-metals, noble gases and metalloids. So some elements are there which exhibit the properties of both metals and non-metals. Okay, they have some properties of metals and they have some properties of non-metals as well. For example, snake. Whenever you see snakes they don't have legs to be called as a reptile, and it just how it works without the leg. So they have major characteristics of a reptile. That's why snakes are reptiles. And then you know about platypus. Platypus actually lay eggs, so actually they need to be grouped under birds, but they are mammals because most of the properties of this one platypus resembles that of mammals. That's why they are mammals. Similarly, there are elements which have both the properties, metals, the properties of metals also, and the properties of non-metals as well. So this type of elements which exhibit the properties of both metals and non-metals are called metalloids. And there are a few metalloids whose use we will be learning today. They are arsenic, germanium, tungsten and antimony. So can you repeat with me the four metalloids? These are arsenic, germanium, tungsten and antimony. Even silicone also comes under metalloids. Unlike metals, they are neither malleable nor ductile nor tenacious, but arsenic is a good conductor of electricity. So unlike metals, they are neither malleable. Malleable means they cannot be beaten into thin sheets. Ductile means they cannot be drawn into wires. Metalloids cannot be beaten into thin sheets. Metalloids cannot be drawn into wire. But arsenic, being a metalloid, is a very good conductor of electricity. Can you name a metalloid that is a good conductor of electricity? It is arsenic. And antimony forms alloys with metals. So antimony is another metalloid that forms alloys with metals. Some of their reactions can be compared to those of typical nonmetals, as for instance formation of stable hydrides and oxyacids with nitric acid. But whenever they react, some of their reactions can be compared to the typical nonmetals. Their hydrides are very stable like that of hydrides of nonmetal. Their oxyacids are also very stable. When they react with nitric acid, they form oxyacids, and acids can be formed by non-metals only. That means here only you can see metalloids have metallic character because they can conduct electricity, they can mold it with metals to form alloy, and again other side they can form hydrides and oxyacids, which is the typical property of non-metal. So metalloids have both metallic as well as non-metallic properties. However, the formation of sulfides from the solution of the chlorides by hydrogen sulfide is a characteristic property of metals. Again, the formation of sulfides from the solutions of the chloride, whenever the chlorides, okay, metalloid, the chlorides of metalloids, for example arsenic chloride, germanium chloride, so when this chloride reacts with hydrogen sulfide, then they behave like that of a metal. That means they have what is the conclusion of this total paragraph is metalloids exhibit properties of both metals and non-metals. Okay, this much only you need to keep it in your mind. What you have to keep in your mind, that metalloids have both metallic as well as non-metallic character. They exhibit the properties of both metals and non-metals, and there are few metalloids. They are arsenic, germanium, tungsten, antimony, silicone, germanium, okay, so on. Yes, now we'll learn about their uses one by one. So here you can see silicone. Here you can see silicone. Silicone is a metalloid and it has a tremendous use in modern days electronics. Silicone chips are widely used and form basis of modern electronic and computing. That means without silicon, electronic and computer, mobiles, nothing will be there without silicon. That means that important is silicon. So being a metalloid, silicon is very, very, very important. When silicon is alloyed with aluminium, it is used in engines, as the presence of silicon improves casting of a metal on a surface. So it can be alloyed with aluminium also. It can be molded with aluminium also. For what? It is used in engines. So the alloy out of silicon and aluminium can be used in engines, as the presence of silicon improves casting of metal on a surface. So whenever this aluminium is to be casted on engine, okay, casted means reshape. You can say first of all you melt it and give different shape, size, that is called casting. So casting of aluminium on metal surface becomes easy, becomes very efficient if there is silicon present in it. When mixed with iron, silicon enhances the iron's magnetic properties. Again, if silicon is mixed with iron, then its magnetic property also increases. Silicon is an important component of steel and provides toughness to the steel. Again, so you can see the uses of silicon out here. Silicon is an important component of steel. Even silicon is present in steel in order to make a steel very, very, very hard, tough, okay, which can withstand a lot of load. So in order to make steel tough, what is used? Silicon is used. Silicon carbide, commonly known as carborundum, is extremely hard substance and is used in abrasives. So silicon carbide, which is also known as carborundum, is extremely hard substance and is used in abrasive. Abrasives means the substances that we use in signing the surface. Signing the surface, just before painting our grills and all, what we do? We use sandpaper. Yes, so this sandpaper are made up of silicone, so this can be used as abrasives. Silica, SiO2 in sand, is the main constituent of glass. Silica in sand and minerals in clay are used to make concrete and bricks. Again, silica in sand. Most of the silicon is present in sand. Most of the silicon is present in sand in the form of silicon dioxide, SiO2. Okay. So silica in sand and minerals in clay are used, and this silica in sand and minerals in clay are used to make concrete and bricks. Pure crystalline silicon dioxide, which is also called quartz, and this quartz has a very high application in making watches and clocks. So pure crystalline silicon dioxide, which is also called quartz, that is to be separated out of the sand only, and is used in high precision watches and clocks. Silicone based polymers have heat resistant, non-stick and rubber like properties. So silicone based polymers have heat resistant, that means nothing will happen if they are exposed to heat. Non-stick, they do not stick, and rubber like properties. Thus they are often used in cookware. So silicone based polymers which contain silicon. So silicon based polymers can be used in cookware, medicine, and as sealants, adhesives. Adhesives means something which we use to paste, okay, to add, to join the substances, the things, lubricants, and for insulation silicon is used. Then another is germanium. Germanium is another metalloid. Okay, germanium is used in the manufacture of wide angle camera lenses. So in order to cover a very large area, okay, by a lens, this wide angle camera lenses is made using germanium. Owing to its similarities with silicon and tin, germanium is widely used in semiconductor industry. So this germanium have some similarities with silicon as well as with tin. That's why germanium is also used in semiconductor industries. Semiconductor industries means industries related to this one only, electronics. Okay. Then the inner coating of the fluorescent tubes allows them to glow. Germanium is one of the important constituent element in such coating. So for inner coating of fluorescent tube also germanium is used. This much for today. Thank you.